Hello, everybody, and welcome to the June 20th, 2023 iteration of the Kubernetes SIG-Windows community meeting. As always, these meetings are recorded and uploaded to YouTube, so be sure to adhere to the CNCF Code of Conduct. For anybody who's new here, that means basically just boils down to be nice to everybody. We'll get started with some announcements. All right, first announcement is last week was code freeze or enhancement freeze, and the next milestone for the 128 release is code freeze, and that is coming up on July 19th. That's about 4 weeks from now, just an FYI for everybody. As I was kind of expecting, the enhancement that I was trying to push through for the volume size didn't get a lot of reviews. I need to push on that again during not the enhancement period. Unfortunately, I think Jordan was he was doing some reviews, but he was out for a while, so I think that was a big reason why that didn't get much traction. But we'll keep pushing for that for next release. I think that was one of the only ones that we were tracking for now. Does anybody else have anything they'd like to announce? Okay, no. Next is usually on these meetings, we've got a space if there's anybody who's new to the community, if they want to introduce themselves or say hi or ask any questions. So I'll give a little bit of space if anybody wants to introduce themselves. Just feel free to unmute or unpause. That's definitely not required. Hello, Jay.
Hello.
Yo.
Yep. Hi, I'm Daman. I'm new to the community, and I'm working on Windows Service Proxy along with Jay.
All right. Hello. And welcome. Yeah, I think we'll probably maybe talk about this. We can some more later. Do you have any questions for the community, or just want to say hi?
He's gonna show us the latest. I'm excited. And it's
I've been working on
VMware too.
Awesome. Yeah, I think okay. We'll do that after we get into the agenda. Anybody else? I think recognize pretty much everybody else on the call. So we'll move forward. David, you had an agenda item for the host process space container image issues. Do you want to bring that up?
Yeah, it's probably not really an issue, but just my lack of knowledge on how to use this correctly. So I was trying to apply, basically a manifest, like a YAML to my Kubernetes cluster with the container image field pointing to the host process base container image. For some reason, it was not pulling it down. So I wasn't sure what the issue was there. But this still works. There are no issues with it, right? I just wanted to confirm.
Yeah, it should still be working. That's what we used to provision like the CNIs for all of the Windows test clusters.
Okay. Yeah, okay. It's probably something on my end.
Your version of container D, there was, I know at one point there was an issue with there were some build tools changed and started pushing the images with I think as always as a manifest list, so that it could include some provenance information as another artifact that was also on there. And that caused some issues with the platform matching logic. And there was a patch in container D. I think it went into 1.6 around version like 1.6.18 to loosen the validation logic for because we just have the single the single image that runs on all the OS stuff. So try and run the latest version of 1.6 if you're on that, or any of the 1.7 versions should support that. And if not, try posting in Slack and mention me, and I'll help you get to the bottom of that.
Okay, sounds good. And the latest image for image version is v1.0 for the base container image, and then for container D, I'll try using 1.7 or 1.6 or higher should work.
Yeah, 1.6.18 or
Okay,
higher.
okay. Yeah, the latest, yeah, okay.
Yeah, let me know if there's any issues.
Cool, thank you.
All right, does anybody else have anything to add to the agenda? Do we want to see a demo of, or what Jay and Damon was talking about? I don't see
Oh
it.
yeah, I'll add it. I'll add to the agenda. Oh wait, we have a new doc. I mean, I think I'm in the old doc.
Yeah, oh, I posted a link to the doc.
Oh, we need to update our Slack URL. I can do that. Wait, where am I?
Wait, the Slack URL has also been updated, right? Or which Slack URL are you talking about, Jay?
SIG-Windows notes at the top of the Slack channel.
Oh,
Oh yeah, I updated the Slackbot reminder and had the bit.ly link to.
Okay, I'm fixing it now. I'm
Okay.
fixing it. Okay, cool.
Let me open up the other one and make
All
sure.
right, I fixed it. Yeah. Okay, cool.
Okay, oops. Fix that up right now.
All right, cool. Man, that's fancy. You and your Bitly link.
I couldn't figure out how to have the Slack reminder do like a pretty name for a URL, and I didn't want to just have
I like
big
that.
do it there, so or a big random thing.
Where are we at? Okay. Okay, cool.
Is there a demo? Should I stop sharing the screen? Do you want to
Cool.
share?
What do you got, Damon?
Let me share my screen.
Are you gonna show it to us?
Yeah. Let me share my screen. Yeah, can you see my screen?
Let's see, an Iron Man background. Yep.
So Damon names all his computers after Avengers robots.
Big Marvel fan, so yeah. So does everyone have an idea about KPNG?
I think most of us like do.
Yeah, but I think it's good to
Yeah.
start with an overview just so that somebody comes back to the recording. It's all there.
So KPNG basically decouples kubeproxy into two different parts. One of them can be brain, which interacts with the API server, watches over all the nodes, endpoint slices, and services. And the other part is the backend, which basically programs the data path. So in order to run KPNG, we basically run two different components. One would be the brain, and other one would be the backend. So currently, I'm working on kernel space full state backend, and which essentially does is like let me go, which let me just do the call back. Which essentially, consumes a full state every time when any event happens, either a node is deleted or added, or endpoint slice is added or deleted. KPNG brain part will trigger this callback. This callback will essentially have the full state, all these services, along with their endpoints which are existing in the Kubernetes. And we will be basically programming the data path for all these services. So to start with, I have this HCN service. I have our own definition of host compute endpoint. Same for load balancer. And same for network. These are basically our own definition of the actual host compute network objects. Then we have this interface. This interface is for interaction with the HCN services, get network by name, all the CRUD operations for endpoint and load balancer. Then we have a concrete implementation of that. We also have a fake implementation, which could be used for mocking and testing and everything. So one more thing, like KPNG also comes with a diff store. Diff store is basically kind of service change tracker. If you guys are familiar with kubeproxy Windows also. They normally have a service change tracker. So diff store is kind of a new generation service tracker, and it's a generic store where you can track state, add items, and after processing everything, you diff store has a API for getting the new objects which are created, the objects which are updated, as well the objects which are deleted.
Yeah. Real quick, what's happening is that like this sort of allows us to do a few things all at once. One is it gives you the potential to have a operating system specific backend like the Windows proxy that does not have to vendor in all of Kubernetes, right? That you could do that. It also gives you the ability to like to have a Windows specific command line options, Windows specific releases for your backend, because this is not in tree, right? So that's the other sort of broader thing. But yeah, and then the full state thing that Damon talked about gives you the ability to say your kube proxy will get the full state of the network every single time, and that something changes, which means it's a lot easier for a Windows developer to debug it and play around with it and figure out what's going on. Because the way the current kube proxy entry works is it has this data model of what services and endpoints are, and it sort of aggregates them into this big map. And nobody knows what the hell's in that map at any given time, right? Unless you go change the code. So that's the overall sort of the way he's cobbled all this stuff, how it all sort of pans out for us in the long term. Anyways, go ahead, Damon. Yeah.
So to essentially program a service in Windows, we have to create host compute load balancer and host compute endpoints. So we have two stores, one for load balancer and one for remote endpoints. We don't track and maintain lifecycle of local endpoints because those are programmed by CNI and we don't want to interfere with that. So we also have methods for adding a HCN endpoint to our diff store, and same for load balancer. So basically, whenever we receive a callback, we try to add things to the diff store. Let's say we received a callback and we iterate over all the services and their endpoints. And let's go to cluster IP service. So essentially, we will iterate over all the pods. Service will have one or more multiple pods. It can have IPv4 and IPv6 IPs as well. Then we iterate over the cluster IPs, endpoints. Then for every endpoint, we create a HCN endpoint. It basically creates a HCN endpoint using the pod's IP. And after creating all the endpoints, we create the HCN load balancer. So HCN load balancer will have the load balancer IP, the list of HCN endpoints, the flags and source VIP, port protocol, and target port. So for programming services, we in full stack backend, we just add all the services which are required to the diff store. After adding to the diff store, diff store has a API method for done, which basically computes all the deltas.
Yeah, the diff store is essentially the thing that replaces the in-memory model of the in-tree proxy, right? Because the in-tree proxy has services and endpoints, and it aggregates them into this one data structure. And then what KPNG comes with, because it doesn't do that for you, is it comes with a thing called a diff store. What the diff store does is it allows you to add stuff to it and then replay it so you can just see the diffs afterwards. So you can get a completely stateless like there's no state in the model of what's going on in the kube proxy. It just reads in the whole network state, and then every once in a while you can just get the diffs out of it in a separate call. Yeah, go ahead. Yeah.
After calling done, basically the diff store will compute all the trackers, all the differences like Jay told, and we essentially call program host compute objects. This function will actually have side effects. It will either create, delete, or update the required components. Coming to this function only, program host compute objects, we ask the diff store about items which were deleted. So we delete all the load balances which are not required. We do the same for remote endpoints, which are no longer required. Then we iterate over all the items which are changed, and then the items which were updated. And finally, we check for the load balancers, which were either changed or deleted, and program the data path accordingly.
Yeah, cool. This is
So
great,
given-
Damon. So Damon's written all this. He rewrote the whole thing in the past like what month and a half? I don't know.
Yeah.
Yeah.
So I have a dev EKS cluster with 2 nodes, one Windows and one Linux. So I have disabled the Windows Q proxy service. And to give a demo, I have a little small smoke test, which has Nginx deployment and Nginx service, and a Windows deployment and corresponding Windows service. So this is a basically whoami pod, which returns the host name and host IP. So let me just apply this manifest. So yeah, in my node, like these 2 deployments are ready now, and these corresponding services are also ready. So if I go here in the PowerShell and if I search for remote endpoint, so the last remote endpoint will be programmed by KPNG proxy only. And to test it out, we can simply just curl it. So we have whoami Windows. I'll just copy the cluster IP part. So the cluster IP returned the status from the endpoint. We can do the same for Nginx cluster IP. That too works. We get a response from Nginx, and we can also try the node put service. So let me just copy the IP of the Windows machine. Here we have Windows Server 2019 and Amazon Linux. So this is the IP for the Windows node. We'll just do curl over here, and the node port would be just 31601. So this
Oh,
is
you got the node ports working. I thought it was just cluster
Yeah.
IPs. Cool. Awesome.
And I can check, try to hit on the Linux IP as well for the node port service. This is the Linux machine. I'm new to PowerShell, so just give me a second. And the node port would be 31601. Yeah, works for both the IPs, Linux and Windows. So right now, like a cluster IP, basic cluster IP and node port services are working. And I will start E2E testing on that, and I have to implement load balancer and external IPs.
This is really
I
cool,
have-
man. Thank you so much for doing all this stuff, Damon. Yeah.
Yeah, I
I
was
have
gonna mention that I believe we have some pull request test jobs set up in the Windows Service Proxy repository that you
Yeah.
can trigger and run like the full set of EDE tests against the changes from the Windows Service
Currently,
Proxy.
we have for this one, this backend kernel space, and I can set it up for kernel space full state, which currently I'm implementing.
Yeah, so we can whenever you're ready. If we don't have things set up, I can help get all the test coverage that we want set up on that repository to make it easier to test or run all the.
Oh yeah, we'll get it all for free, Damon. Yeah, if we just
I need to double check everything. I know we have a periodic job that's set up. I thought that there was a pull request job, but if not, we
I
can work
think
on
one
getting one
pro
set up.
job for experimental group in Windows Node.
What was that?
I think there's already one job for the kernel space backend, and it falls under the experimental section.
Yeah, we can get other ones set up for the full state too if we need or want.
But I think this is so much better than that initial hack copy thing that we did, Damon. I think just delete kernel space and replace it with yours, and nobody's going to care, right? That way we don't have to write any extra code for a new CI job. The other one's broken anyways, so you can't be any worse than the one that we already have, right? Like,
makes sense.
it's already better in the sense that there's somebody working on it, right? Like,
yeah, true.
And then you don't have to do anything. Just delete the old, make your PR, delete the old code, and then the CI will run automatically. Cool.
Cool, I'll do that then.
This is great.
Hey,
It's great to see a lot of progress on this.
Thank you, thank you.
Yeah.
They run this locally first, then set up the cluster job, testing job, CI job.
I don't think you have to set anything up. I think if you literally just change your pull request to delete the old, to overwrite all your code into kernel space, I
Okay.
think that will literally do everything that you need.
I
Right, Mark?
think too, if not, there's that PowerShell script that runs when the container starts.
Yeah,
Just
that
tell
should
that
be
to
into
you. Yeah. We could either update that to take a switch to use the old one or the full state, or just update the deployment to use the full state.
And also one question, like there are some hard coding, as in the host network identifier needs to be hard coded in the environment.
Yep.
So I have to figure out a way for that also. The cluster cider will be already there, the network name and the host IP, I guess, the endpoint IP. So that will be different for different vendors. Like I guess the current testing is implemented with Capzi, Calico, and like I'm not sure which value I need to add over here. So I might ping you guys for that also.
Yeah, and I think I was mentioning this with Claudio at the beginning of, or during the triage session too. I think we need to find a more generic way to handle this. Like the issue is that if the cluster first comes up, we need a way to talk to the API server, but the in-cluster config and the environment variables here point to like the internal service IP, which we don't have a route for. So we need to figure out how to be able to contact the API server. In previous deployments, like in the Calico implementations for what we have in the SIG-Windows tools, we just pass it in a kubeconfig that has the external name. I don't know if we want to do that here too, or if there's something better that we can do the first time.
Well, in CapZ, if it's CapZ, can't you just, could we do something where you talk directly over localhost because the API servers? Oh no, it's not.
That would be the worker node only, the local machine.
Yeah, you can do that.
Yeah. So there's still that issue. We can solve it the old way or figure out a new issue too. But I don't think that should block any progress on getting actual implementation and things working.
Well, I'll try multiple things out, whichever works the best. We can go with that.
Mm-hmm.
I guess until then, maybe the best thing to do is to assume that CI might lag a little bit, and maybe manually testing it is a good idea. Because there isn't.
Initially, to start with local manual testing only. I have a dev cluster and I can test run E2E on that only.
Yeah.
Just
Okay. Cool.
Does anybody else have any other questions about the Windows Service Proxy work?
Yeah, I have
like Jason, it's
question.
really good to see people working on it. So sorry, go ahead, David.
Yeah, sorry, I was muted. So yeah, this looks really good. Thanks for working on this. And I had a few questions. So which network mode is this using now?
L2 bridge.
Okay, so L2 bridge. And it looks like there should be considerable performance improvements as well with the diff store that you're using versus the current in-3Q proxy. Have you done any measurements yet on that, or I know it is just the first demo, but
this is the first demo only. But I'm aware the diff store has a B-tree implementation and it should be faster compared to the regular proxy.
Okay, cool, exciting.
I don't have any stats as of now, but yeah.
I think the biggest thing that I think could be a performance improvement would be that we could completely remove any watch someday from the Windows Service Proxy, right? So that it was all purely done over gRPC. But you talk to Mark about that. And the big performance improvement there is just that it takes less resources. So you could use those resources to dedicate them to other things. Or you could just, rededicate them to the kube proxy. But the thing there that we talked to Mark about is that would require sort of changing. If we were to go to that extreme, we would change the deployment change the way that Windows thought about running its kube proxy entirely, because then you would have a Windows node that was really completely disconnected from the Kubernetes API server entirely. Right, and then so
Might
Okay.
make sense, but I think one step at a time.
one step at a time, right? Yeah.
Let's get the rule programming stable first.
Yeah. Yep.
Great. All right, and I think that brings us to the end of the community meeting. So I think leave it at that. Yeah, thanks for the pull request too, Damon. I'm checking it out. And yeah, all right, everybody have a good week and see everybody next week. Thanks for the demos.
Yeah.
Bye.
Cool.
I
If
thought-
folks need anything, I can stick around a couple of minutes. Otherwise, I'm going to drop.